Hi, I'm here to talk to you today about the Perseverance mission, which is going on to Mars, and that's very, very exciting. I always get excited about different missions for lots of good reasons, in the fact that it's an example of how people work together for a common goal. And it also means that if we can explore our neighborhood, our solar system, Earth's neighborhood, the more we learn about Earth. So today, I'm going to talk about Mars. Why is that so special? And I'll give a little overview of some of the history of the exploration. And then Perseverance, we're going to talk about its four main objectives. We're going to talk about the instruments, the landing, entry, and descent, which is very hard, and then Ingenuity, which is kind of cool. That's a little helicopter. And then, how are we really going to get to Mars? In other words, if the goal is for future exploration for humans to get to Mars, what are some of the things that need to be in place so that we can get there? And then, lastly, how can we be involved with the Mars mission on February 18th, 2021? So let's talk about Mars. It's the fourth planet from the Sun, and it's the second smallest planet in the solar system. And it got its name from the Roman god Mars, and it's described as the red planet because of the reddish appearance. It's a terrestrial planet. And it also has the tallest mountain in the solar system, Olympus Mons. Now, this is a diagram showing our solar system. And if you see that green ring, here's my pointer, and Earth is in that, and that's called the Goldilocks Zone. We happen to be in our solar system at this point in time in the universe in the exact spot so life can happen. It's not too hot, too cold, or when it is hot, we can adapt to go ahead and live, and we can breathe and living things. And so it looks like that Mars is in that range, but it's still going to be difficult because going into space, it's hard. It's a very hostile environment. The mission to Mars, and here we've had a lot of people explore Mars. And here's a diagram that I can show you. Look at that. Who's invading who? There have been 56 missions to Mars, not just from the United States, from all over the world, different countries have participated. 26 of those have been successful, which means a lot a lot is at stake. It's very hard. And those that didn't reach their goal or in a sense failed, we learn a lot from that. In science, that's what we need to understand is sometimes things are not successful. And so we need to go ahead and learn from all of that. So hopefully Perseverance, which is going to land on Mars, will be there we go. And this is another diagram of kind of some of the current orbiters that are currently around Mars, and then the landers that are currently working. And if you see those ribbons, our ultimate goal in the last ribbon is to prepare for human explorers. And we've done that by dividing it into three main themes. First, we follow the water. And then we explore any possibility of habitability. there resources on Mars that we can use? And then we seek signs of life. That's always a big question. Are we the only ones? Now, Perseverance is about the size of a compact car. It weighs about 2,260. It's 10 feet long as you don't exclude the long arm that it has. It's 9 feet wide. And it was launched last year, July 30th, 2020. And it's going to be arriving in February 18th, starting at 2:15 p.m. Eastern Standard Time. And at the end of this presentation, I can show you how you can watch it, how you can be involved in different events, how to celebrate it, and how to share that if you want to. The mission duration is at least one Mars year, which is 687 Earth days. Now, this is a video we have that talks about the difficulties in once we get into the area of entry, of descent and landing in Mars. It's very difficult. This is a video that really describes, first of all, Curiosity, which is very much like Perseverance. In fact, Perseverance was tailored because of the success of Curiosity. And so this gives you an idea that now that we have Perseverance near Mars, let's see if we can get, okay, let me get back to previous and click on there we go.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow constraint space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it will only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical diversion. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the Skycrane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage, it's in a collision course with the rover. We must cut the bridle immediately and fly to the descent stage to a safe distance from the rover.
Wow. I don't know, my heart is beating fast because that's exciting. And you can the video demonstrates the kind of teamwork that is really necessary and the intricate hard work that they do. And so it's just an amazing feat. So hopefully it will be totally successful. And that's what we have to think about. There are 4 main goals. Now that we have the rover on Mars in this presentation, I'm going to just explain generally what the main goals are, and then I'll go into the instruments. First of all, they're going to determine whether life ever existed on Mars. And it's going to focus on surface-based studies of Martian environment, seeing preserved signs of biosignatures in rock samples that are formed in ancient Martian environments with conditions that might have been favorable for microbial life. The next one is they're going to look at the climate at Mars and how it's really changed over the years. And they're going to look at the geology. And I'll go into more detail on that with each of the instruments. And then they're going to figure out the kinds of things that are needed to take humans to explore, because their goal is in the 2030s to have human exploration toward Mars. So now there are 7 instruments on the Perseverance. And so I'm going to be talking about those as soon as I find my notes here. Here we go. And I'm going to talk about their goals. I'm going to talk about where the names come come from. And you have teams of people working in various countries to put this all together. So this is not just a NASA um, project. We have people from different countries working on this. So let's talk about the mass cam. And this was the principal investigator was Jim Bell. And its main goal here, and you see at the head, there's my, right there. Its main goal is to take high definition video, panoramic color, and 3D images of the Martian surface. Now, the thing to know is it's going to be able to pick out the best rocks, because what they're going to do is take those rocks and core them and save it as a cache. And so for a later mission to go ahead and pick up those and return to Earth. So they're going to collect all the materials and all the cache. They're going to hunt for places for life. Earth or the mass cam can understand the terrain around the Perseverance rover, such as the rock and soil textures. Those clues will help show Mars if could have supported tiny life forms long ago. It's going to look for water signs in ancient lakes, streams, and related features. And it has very sharp vision. In fact, it could see a housefly as far away as a soccer field. So that's pretty amazing. And then it has the ability to be all-seeing, because those eyes can make a 360-degree circle and a full 180 degrees from straight down. Okay, so if you think of the mask, it's on the mask at the top there, and the cam, which is a camera, and it looks like little main eyes. It's located at the top. Its camera system and its zoom capability, that's why we have the Z to mark. So this is what they call Mastcam Z. The next instrument I want to talk about is MEDA. It's the Mars Environmental Dynamic Analyzer. And it's going to measure the weather and monitor dust with sensors from the Mars surface. So Mars has a very dusty environment, and it rules the weather. Like water kind of rules the weather here on Earth. And so we have to understand the water cycle and what it does with all the temperature relations and all the factors that are involved. So this time, this instrument will study the dust, the difference, because it drives the processes of the surface and the atmosphere and affects the temperature and the weather. So dust is a major factor that they have to deal with. It's very fine, and they want to study the dust cycle. It's going to help predict the weather. It'll help astronauts whenever they get there to weather conditions, what kind of conditions they'll face on Mars. And their safety depends on accurate predictions. And MEDA is going to measure the radiation, which is another hazard. Radiation from the sun in space can alter the traces of any past life in the Mars rocks. So MEDA will help scientists understand those kinds of changes and kind of look for them. And MEDA will measure the water vapor. MEDA's humidity sensor tells how water vapor is exchanged between the soil and the atmosphere of Mars. So meta is taken from two Spanish words that roughly translate to give me. So meta, so give me weather, dust, and radiation report on Mars, and that's what it's going to do. Jose Rodriguez Manafet from Spain was the principal investigator on this one. And Moxie down here underneath. Moxie is Mars Oxygen Insuit Experiment, and it's an experiment. It's going to produce oxygen from the Martian carbon dioxide atmosphere. And when there's a quote from the principal investigator, Michael Hesh, when we send humans to Mars, we want to return them safely. And to do that, they need to rocket to lift off the planet. Liquid oxygen repellent is something we could make there and not have to bring with us. One idea would be to bring an empty oxygen tank and fill it up on Mars. So it's going to make oxygen. The Mars atmosphere is 96% of the gas in the Mars atmosphere, and the oxygen is 0.13%. Now keep in mind, in Earth it's 21%, so 0.13. So this is going to be an experiment that will test whether they can produce oxygen, which would be helpful for life on Mars and for the future explorers and for getting back. And this is a test model. It's about the size of a car battery. Moxie will help future explorers. They will need about 33 to 50 ton of fuel, which is about the weight of the space shuttle. So think of Moxie like a plant or a tree. It's going to take in carbon dioxide and it's going to exhale oxygen. Homemade liquid oxygen on Mars could supply more than 3/4 of the propellant humans need for exploration on the red planet. And so its name is short, it's a snappy name, and the M is for Mars, of course, and the OX is oxygen. It works in place, insuit, and then the E at the end stands for experiment. Moxie is also a personality trait. Someone with moxie is considered to be bold and adventurous, hardy and spirited. So if you're going to explore on Mars, you're going to have all those qualities. The next instrument I want to talk about is PICTL, the Planetary Instrument for X-ray Lithochemistry. And that's over here. Whoops. All right, here, let me get back here, previous, because I'm not done yet. Here, over here on the arm, the bottom side of the arm. It's to measure the chemical makeup of rocks in a very, very fine scale. And Abigail Atwood was the principal investigator. If you're looking for signs of ancient life, you want to look for a small scale and yet detailed information of the chemical elements present. So it's going to detect past life. It's going to see changes in textures and chemicals in Martian rocks and soil left behind by ancient microbial life. It's compact, it's tiny. This is about the size of a lunchbox, and it weighs about 10 pounds. And those, when you compare those on Earth, they are about the size of a beach cooler and weigh 500 pounds. Pickle is very flexible. The X-ray beam moves as easily as a laser pointer in a scientist's hands. Tiny motors will give it the freedom of motion, like a mini version of a six-legged motion control flight simulator use. And it will see the super small. The X-ray beam can focus on rock features as small as a grain of salt that let Pixel find tiny traces of life that microbials may have left behind. So Pixel far exceeds other tools. And so it's going to be able to detect at least 20 chemical fingerprints, even when the amount is only a few parts per million. It finds the exact tiny spot in a rock where the chemical is. All right, and the next one is rim fact. And this is by Svein Erik Hamran from Norway. And its main job is to see the geological features under the surface with ground penetrating radar. No one knows what lies beneath the surface of Mars, and now we can finally be able to see what is there, quoted by the investigator. So it's going to see underground, just the explorers probing below Earth's crust. Scientists can use this radar instrument to see unexplored worlds that lie beneath the Mars surface. It's going to try to detect water and ice. It works a lot like the radar on Earth. And it's the first time they've used an instrument like that for Mars. So, and its name is from a Norse mythology. Remfax is a name for Hrimfaxi, which is a horse, and is a faithfully that brings the night. And its sidekick is Skinfax, which is a horse that brings the day. And it means ones with the shining mane. So, and then we have Sherlock. This is the scanning habitable environments with Raman and luminescence science for organics and chemicals. And its job is to fine scale detection of chemical minerals, organic molecules, and potential biosignatures. The driving questions are whether Mars is or was ever inhabited, and if not, why not? The Sherlock investigation will advance the understanding of Martian geology, history, and identify the past biological potential. So this one, Sherlock over here, works all shifts, day and night, and it has an eye for detail. So there's a magnifying glass in a sense. And it's going to collect clues. So its name is based on a fictional character called Sherlock Holmes. And it has a camera, a sidekick. Can anybody guess what that sidekick's name is? It's a camera. And if you thought about Watson, that's it. So it's there to solve problems about identifying past biological life. Now, we know about the instruments. We have the Perseverance in this presentation already landed. So now this is a video that will give you an idea of where they're going to land, how they're going to do it, and what they're going to explore. Here we go. Oh, well, this is wrong. So let me go back here. Let me go back and see if I can find it. Lower here. Here we go. There, I got it. This gives you an idea of the area they're going to land with at the Jezero crater. And this is interesting because this is not just flat land. It's a river delta, and there's high cliffs right there. And so they're getting adventurous as to where they're going to send their landing. So
this flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high, and are the rim of Jezero crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact, and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
okay, and what's interesting to when you watch these videos that I think are really stunning is the fact that besides engineers and scientists working together, you have to have people with the talent of being able to make animations, to use art, and to communicate. And what they have to do is listen to the scientists so that they can translate these into videos and media that we can understand as a general population so that we can be more science aware and literate. So anyway, here we go. Now, any mission that has ever been done in here always has kind of a contest of naming it. And so this was a very stunning um, essay that this young lad, a seventh grader, Alex, who created. And I thought this was important to use because it's young people and their interest in how they get involved with this. And so this is how the rover got its name.
NASA's newest rover is gearing up for its journey to Mars.
That's the wrong
We've been
video.
building the
All right. Here we go. I got it right. All right, here we go.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future. My name is Alexander Mather, and that's why I chose Perseverance as the name of NASA's next Mars rover. I don't really think that there is a word in any human language that can describe the feeling of having your name selected to be part of a mission from the greatest agency in the world, doing the most important things to help humanity spread to the stars. I am 13 years old, and I did not expect that I would be making any form of impact on human space exploration like this until I was at least out of college, or maybe in an internship. And here I am, and I've just named a rover. Something I submitted was chosen by people who one day I plan to work with, and that's incredible. To me, perseverance means that in the inevitable setbacks that we're going to face on the main way to Mars, humans won't give up. Humans will keep on sending new missions, humans will keep on improving technologies, and humans will eventually live on other places throughout the solar system, and maybe even beyond. And that's just so important for all of our futures.
Here we go. All right. All right. It's amazing how a young lad gets so wise, and they were able to put an entire video of the history of human beings and how he was so insightful. And that to me is the point that we need to get everybody, young people, involved. Can I'm gonna This is the Ingenuity, which was also named by a student, and I have a quote from her on this. Can anybody tell me, when they look at that little helicopter there in that picture, is there anything on Earth that it makes you think of? Anything in the environment? it looks like an insect. And that's exactly what scientists did. They looked and studied at the things that are happening right around us. And we learn from that, and then we can apply it to a new world. And so this is an experiment. It's a prototype. The goal is to fly at least 30 seconds and up to 3 meters if possible. Now keep in mind the Wright brothers, their first flight was 12 seconds. It's the first powered test flight on another planet. It weighs less than 4 pounds. It's got to take off, it's going to fly and land. And that's the goal, and it will take pictures. By the way, the Perseverance has 23 cameras. There are 9 of them that are engineering cameras, and 7 science cameras, and then 7 entry, descent, and landing cameras. This was named by a high school student, Vanessa Rupani, and this is part of her quote from her essay. I couldn't find a video of hers. So, the ingenuity and brilliance of people working hard to overcome the challenges of interplanetary travel are what allow us all to experience the wonders of space exploration. So I wanted to recognize her, and I wish that there would have been another video. And here we have a short video on what its goal is. Okay. Now, this website, which you can go to, and it's just if you just Google into Mars 2020, this gives you the resources. It talks about the landing, it talks about the timing, it's a toolkit. You can also click on ways to participate, and if you mission to Mars student challenge, there is a countdown and ways that you can watch this. So this website, which is Mars 2020 timeline and landing, will give you the resources that you can do that. If you're a classroom teacher, there's whole units that you can use, or you can use the lessons individually. Let me click on one of these. There we go. Okay. And there's a countdown also after landing. There we go. So that is a good resource for when you're getting ready. And there's the toolkit that you can use, and there's facts, there's stickers, there's ways that you can share any photos of how you celebrate this event. And this gives you an idea. This is just a graphic that shows you the involvement of our goal in the 2030s, late 2030s, to get to Mars. And so we're going to be going to the moon first, which is the first landing of the moon will be in 2024. There are 5 main hazards in human space flight. And besides the radiation, you've got your loneliness of distance from the Earth. You have gravity, what your body, how it's affected by the less gravity, and it's very hostile of its environments. And these are currently being studied here on Earth, but also the International Space Station, which is in its 20th year of having people on board. 2020 in November was the 20th year of human presence, and it's a living, moving laboratory. And so we have benefited from that. And there are 7 areas of research of which they're going to currently be working on off and on. And now that we have the ability through the commercial crew program to bring our astronauts up there more readily from our own country, we're able to have more astronauts up there, and there's currently 7 up there. And that's a picture of the Dragon. We go forward to the moon and deep space, and then on to Mars, to the Armistice program. And Armistice is the twin sister of Apollo. So here we have the countdown and the Mars, where you can get involved and find out if we're successful or not, and celebrate either way, whether, because we're all going to learn from it. And that's it. Thank you.